Today we're going to be looking at section 6.6, which is graphing sinusoidals, but including now a phase shift. Let's just review all of the steps that we've always done so far. When we did section 6.4, 6.5, the first thing we did was draw the sinusoidal axis. Don't forget, you can call that the midline if that helps you remember. But we draw the sinusoidal axis, or the midline. We use a dotted line. The next thing we did was we used the amplitude to determine the maximum and the minimum of the graph. And those are dotted lines equally spaced apart. And amplitude is always positive, so we would do the sinusoidal axis plus the amplitude to find the max, and sinusoidal axis minus the amplitude to find us the minimum. This next step is the new one. This is the one we haven't done before. We're going to determine the phase shift. Our graphs won't be starting at the y-axis anymore. Our graphs are possibly going to start somewhere else, and we're going to find the phase shift to get us there. Remember, the sine graphs still start on the sinusoidal axis, though, no matter where that is, and cosine graphs will start at either a maximum or minimum point. After we have determined the phase shift, we're going to add one period to the phase shift so we know the end of a cycle. So we know the start of the period is at the phase shift. We're going to use the end of the period by adding one period to whatever the phase shift was. Last but not least, we'll divide the period by 4 so that we can find our quarter period. And then we would add that to the phase, we would keep adding that to the point before it so we know all of our values. I don't know if you remember, but the letters were y equals a times the sine of b in parentheses, x minus c, close parentheses, plus d. Let's just go over what all of those things are. A is our amplitude. The amplitude tells us how tall it is. B is our period constant. It's not the period, it's the period constant. It helps us find the period by doing 360 divided by b. 360 divided by b will equal the period. C is the phase shift. Please notice that this says x minus c. It doesn't say x plus c, it says x minus c. We're going to do the opposite of what we think here. And last but not least is our sinusoidal axis, our vertical shift. So let's take a look at this problem right here. We have a full and complete equation. It's got an a value, a b value, a c value, and a d value. And notice over here on the side, I've asked for the sinusoidal axis, that's a. I'm sorry, d, that's d. Sinusoidal axis is d. I've asked for the amplitude, which is the a value, the phase shift, which is your c, and the period, which is 360 divided by b. It's not the b value, but it's 360 divided by b. So, in our equation, there's the d value. Our sinusoidal axis is at 3. The a value is right here. Amplitude is 5. The next step, remember here, said use the amplitude to find the max and min. So I'm going to come right here and put max and min. 3 plus 5, my maximum is 8. 3 minus 5, my minimum is negative 2. Now I can already draw my phase shift. Already draw my sinusoidal axis at 3. I can draw my maximum value at 8 and my minimum value at negative 2. So I already have a lot of values. The phase shift happens at x plus 1, means that the phase shift is actually negative 1. So we need to move our y-axis a little over this time because we need a tick mark right here that's negative 1. That's our first location. It's our starting point. After that, we're going to find 4 tick marks. So here's 1, 2, 3, 4. Notice I did not count this one. This is our starting point. 1, 2, 3, 4. And I know that the period length is 360 divided by 30, which is 12. but it's not location 12. To find where it's going to end, I'm going to add 12 to the phase shift. So what is 12 plus negative 1? 12 plus negative 1 is 11. So my graph is actually going to end at x is 11. It started at x is negative 1, and it ends. Actually, this is just one cycle. We're drawing one cycle of the graph. It's going to start at negative 1, and it's going to end at 11. Okay, so we're graphing a sine equation. Start at the midline, then up above the first tick mark, midline, down below the next tick mark, midline. And there's the sine curve. If you look at it, it looks just like sine curve has looked all along. The only difference is it started at negative 1 instead of 0, and it ended at 11 instead of 12 because everything has been shifted left 1. Well, where are these other numbers? I've got negative 1 right here. The quarter period is 1/4 of 12. That would be 3. So I take negative 1 plus 3 is 2. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. That's how I know that I have completed one full cycle and all of my critical points have been marked. And if somebody were to say, well, what's that critical point? I could tell you it's at 2, 8. And what's this critical point? It's at 8, negative 2. See them? 2, 8, over 2, up 8, and over 8, down 2. This next equation is almost exactly the same. So how is it different? Why do we have this on our notes? Notice in our notes it said b parentheses x minus c. And this is parentheses. I have to move that 15 to the outside. I need to rewrite this equation as 8 cosine 15 parentheses x. But if I divide the 15 out of part of what's in the parentheses, I have to divide it from the other number as well. So I'm going to do 60 divided by 15 leaves me negative 4 minus 2. Now, why do we have to do that? Because this problem looks like there's a phase shift of 60 to the right, when in reality, the phase shift is only 4 to the right. This is a good equation. Don't tell you that that's a wrong equation. But if we're going to find A, B, C, and D, just like we did in our notes, then B has to be outside the parentheses. All right, well, we can look at it now. Here's my D value is sinusoidal axis, amplitude is A, phase shift is C, and the period is 360 divided by B. So the sinusoidal axis, negative 2. Amplitude, 8. Let's find our max and min from that. Negative 2 plus 8, negative 2 minus 8. The phase shift is right 4. The period changes as well. So 360 divided by 15 is 24. Now that means that my graph is going to start at 4 and end at 28. Don't forget to add those two numbers together to find out where my graph is actually going to end. It's going to start at 4, end at 28. And then the quarter period, meaning each tick mark, is going to be worth 6. So I'm going to start at 4, add 6, add 6, add 6 until I get to my ending mark. So here we graph it. My midline right here is at negative 2. My maximum is at 6. My minimum is at negative 10. And I'm going to start my first mark at 4. That is not one of my 4 quarters. That is just the starting mark. After that, I'll go 1, 2, 3, 4. It ends at 28. Don't forget 4 plus 24. 4 plus 24 means it's going to end at 28. And this was cosine, so I'm going to start with my graph. Let's draw it in there. Up, middle, down, middle, up. There's my graph. And the only thing that's missing is my critical points. So 4 plus 6 makes this 10, plus 6, 16, plus 6, 22, plus 6, 28. And we have the whole graph, and if someone were to ask me, I know this point right here is at 28, 6. And you could name the rest as well.